Bismillah Rahman Rahim. In this session, we will discuss chapter 22, which is a sequence and number patterns. This is exercise number 22.1 from Hodder's Educations for O-level mathematics and IGCSE mathematics. So in this exercise we will see some sequence and patterns. Find the terms to term rule for each of these sequence and give the next number. Suppose we have a 2, 6, 10, 14, 18 and 22. This is usually this kind of sequence are asked in a IQ level questions or artificial intelligence. So this is very simple, very basic level, and it will raise to the difficult level in a later part of this chapter. So for this we have 2 to 6 we have a difference of +4, and from 6 to 10 we have +4, and then add +4 to get 14, 14 plus 4 it gets 18. So we can see this the difference is 4 here. So we are adding +4 to the current term to get some next term. So till then this is 26. The next term is 26 by using term to term rules. So secondly for this and for the last one, see. So 4 to 9 and 9 to 15. So we are adding this to get. So this is the next number that was required. So second in the second question, the term to term rules for this one. So this is 3 power. This is 1, 3, 9, 27. So we can see that this is 3 power 0, which is 1, and 3 power 1 is 3. 3 power 2 is 9. 3 power 3 is 27. 3 power 4 is 81. So actually the power is increasing. The power of 3 is increasing in this sequence. So this is some kind of geometric progression. So here we are getting this. So similarly for this one, this is 6 power 6, which is 729. So this power is increasing. Similarly for this one, this is dividing by this 5 to get the next term. So this divide by this to get the next term, divide by this to get this term. So this is basically the current term is divided by the 5 to get the next term. So eventually this term is generated. For this one, 1, 2, 2, 4, and then 3, 4. We are actually sequentially adding, increasing it. For 1, 2, 3, 4, 5, 6. So this in this pattern the numbers are increasing. So the next number is 22. So up till now this 16 is available. So we are deciding what will be the last number. This is 22 as per this sequence. So we are learning it, and we see that the patterns are increasing this way. So the number 3, some numbers are missing here, and we have to estimate what should be the number there. So the missing number in each of this sequence, so 7 to 12 and 12 to 17. You can see that the difference is +5. So this is arithmetic progressions, and then we see that this is +5 +5. So this should be 22, and this should be 27, that's 32, and then 37. So this missing number has been placed here, and this 25, and then so we can see this is this -3 we can estimate that the number should be -3 here. So this -3 will be this. So this is 22. So similar with this. That's for this way, this multiply to get 4, and then 4 multiplied. So actually we are increasing 4 power 0, 4 power 1, 4 power 2, 4 power 3, 4 power 4, 4 power 5, 4 power 6. This is the way that the number patterns are increasing. So this is simple. Explain how do you know whether or not the 77 in each of these sequences. So the number 1 sequence is this. So we can see this is increasing 7 by 7, 7, 7, 7. So increasing to get the new term. So eventually this 70, after 70 this 77 term will be here. So this is second term is 14, 18, 24, 22. So adding 4. So we have an even number, and we are adding the even number. So it's apparently feels that there would be no 77 term in this sequence, so no 77 in this sequence. So we can also estimate by this one. So this is actually the 4n is increasing every time. So n is 1, 2, 3, 4, 5, 6, 7, 8. So we are increasing at multiples of 4 every time. So this is 4n, which is adding to this 4. So eventually this is not equals to 0. So we can prove that this n is not equals to whole number. So this 77 will not appear in this second sequence. This is the demonstration type, and this is mathematical proof that it will not be appear any time. In part A, it can easily be seen. Similarly for this is for part B. So we perform this operation for the part A. So for part A, this is 7 plus 7n is equal to 77. So we can see this is simply because the 7 is adding every time. So this is 7n, and n is increasing 1, 2, 3, 4, 5, 6. So this is this. N is, so whole number is coming. Yes, the sequence is contains the term 77. Suppose we ask that this is 777 or 7 higher order, very later stage numbers. So then we cannot perform this addition to the 100 position. So for this kind of operations, this will be helpful. Look at this sequence of the numbers. So this is 1, 4, 9, 16, 25, 36. So we can see this every time the number square is increasing. So this is 2 square, 3 square, 4 square, 5 square, 6 square. Similarly, this should be the 7 square. By the number of the sequence, so this sequence has appeared as 49, that is 7 square. And all the number of the sequence number is increasing sequence. So so this is the reason why this is square numbers. It apparently shows here. Linear sequence exercise 22.2, which of these sequences are linear and which are not. For each sequence, write down the next two terms. So this is 3, 5, 7. So the difference is 2, 2, 2. So eventually after 9, the 2 will add to get 11, and 2 adds to 11 to get 13. Similarly for this, minus 3, minus 3, minus 3, minus 3. So we'll minus 3 to get. So sorry, here we have this 30 and 10, 28. So this is not, because 40 minus 2 and then minus 3. So this is non-linear, because sometimes the numbers have changed from 3 to 2 or minus 3 to this. So this could be written down like this. So this is non-linear. Similarly for this 78, 75, 70 and 3, all the time the 3 is subtracted together. So this is linear. Similarly for this one, this is linear. For this one, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square. So this is square terms. Square terms always gives non-linear behavior. This never goes in a slope, straight line. The linear usually follows a straight line. So this is not a straight line. So this is non-linear, but the pattern should be this. So this is because every time this number square is increasing. So number squares. Every increasing number squares. So we are getting non-linear relationship. Similarly for this one, this is 1, 6, 15, 28, and then we have to estimate this one. So we can see that the difference is 5, and there the difference is 9, here the difference is 13, here the difference is 17. So every time the 4 is increasing, here we have seen that this 4 is increasing, the 4 is increasing, 17, then 26, so 4 is increasing. This is non-linear, so this should be 17 and then 21, this is 16. So this 17 is added here to get this 45, and then 21 is added here to get 66. So this is non-linear, and this is second order terms. Second difference added here. So this is 2, 9, 16, 23, and then 30 and 37. So add 7 is added sequentially. So this is linear. So nth term is important. In this 22.2, we will discuss some nth order terms. So each of these in the formula for the nth term of sequence, find the first 4 terms of each sequence. N plus 1, so this is n is 1, then it becomes 2, and when n is 2, this becomes 3, when n is 3, this becomes 4, when n is 4, it becomes 5, and similarly for the other terms. So this is 2n. If n is 1, this is 2, when n is 2, this becomes 4, when n is 3, it becomes 6, when n is 4, then it becomes 8, and then n is 5, then this becomes 10, when n is 6, it becomes 12. Similarly for this one, if we put 1 here, so this becomes 2 minus 1, 1, 2, 2 to the 4 minus 1, 3, 3 to the 6 minus 1, 5, 4 to the 8 minus 1, 7, 5 to the 10 minus 1, 9, 6 to the 12 minus 1, 11. So this way the odd numbers are generating. This sequence is generating even numbers, and this sequence is generating odd numbers. This kind of loops are used in a mathematical programming, very important. So this is nth term, so this is n plus 5. So when n is 1, 5 plus 1, 6, and when n is 2, this is 7, 8, 9, and similarly for this one, when n is 1, this becomes 3. This will get the multiple of 3. So this is 3, 6, 9, 12. Here we have multiple of 6, 3, and plus 1. Multiple of 3 plus 1. So this is when n is equal to 1, this becomes 3 plus 1, 4. When n is equal to 2, 6 plus 1, 7. 3 the 9 plus 1, 10. 4 3 the 12 plus 1, 13. 5 3 the 15 plus 1, 16. So this is the way the patterns generate. So similarly for this one, when n is equal to 1, this becomes 5 minus 3, 2. When n is equal to 2, 10 minus 3, 7. When n is equal to 3, 15 minus 3, 12. When n is equal to 4, 20 minus 3, 17. When n is equal to 5, 5 the 25 minus 3, 22. Simply the sequence will add. So 10n, so when 1 is 1, 10. When n is 2, 20. When n is 3, 30. When n is 4, 40. When n is 5, 50. So this is 5n minus 7. This is yes. So this is 2 minus n. When n is 1, this is 2. When n is 1, this is 1. When n is 2, this becomes 0. When n is 3, this becomes minus 1. When n is 4, this becomes minus 2. When n is 5, becomes minus 3. Then minus 4, minus 5, and then so on. So for this one, let's move to problem number 17. 6n plus 5. When n is 1, 6 plus 5, 11. When n is 2, 12 plus 5, 17. When n is 3, 18 plus 5, 23. When n is 4, 24 plus 5, 29. So this is the way the number generates. 5 minus n, and when n is 1, 4. When n is 2, 3. When n is 4, 3, 2. And when n is 4, this becomes 1. So this is countdown. We can see this is countdown. 4, 3, 2, 1. This way the numbers are countdown. So we have a higher number and then countdown for like this. So every time the numbers increase, actually the resultant decreases. So this is 10 minus 2n. So this is 8, 6, 2. So even number countdown. So this is n square. So n square is 1, 4, 9, 16, 25, and then 36, 49, and then 64, 81. So this is n square plus 1. So this is 3. This 2 is added here. 2 is added here. 2 is added here to get this. 2 is added here to get this. So this is the way that is. So n square minus 5 is this is really. So next, the last one is important, n cube. So this is 1, 8, 27, 64. Then 5 is 5 power 5, 25, 125, and then next one. So we're finding the formula for the nth term, and this is the formula for the nth term of each of these sequence. So 1, 2, 3, 4. So we can say that Tn is equal to an plus b is the term. So for n is equal to 1, this is here for term number 1. So this is term number 1, which is called T1 is equal to a, and n is 1 here. So this is 1 a plus b. So this is t1 is basically the 1. So we will write in place of t1 is equal to 1 is equal to ab. For term number 2, this is term number 2. Here we have n is equal to 2, and for n is equal to 2 we have 2 a plus b. So here we have one equation and two simultaneously solve to get a and b. So we will solve this equation number 1 and 2 simultaneously to get the value of a and b. So by subtracting from 1 from 2, we will subtract this equation number 1 from 2. So we will get the a is equal to 1, and from this from equation number 1 we will place the value of a is equal to 1. So we get the value b is equal to 0. So a is equal to 1 and b is equal to 0. So this is the solution. So we will place the value of a is equal to 1 and b is equal to 0 here. So this number is equal to n. So tn term becomes tn. So this tn is equal to n. So we'll place this value here a, and here we have placed this value b. Here we have b, and this is a. This 1 is a. This is the formula. So in place of a and in place of b, we will place these values, respective value. But we have obtained, a is obtained 1 and b is obtained 0. So when place a in place of a we place 1, so it becomes tn is equal to n plus 0. So this is n. Tn is equal to n. So this is the first part. So for this one, 2, 4, 6, 8, 10. So for this one, for n is equal to 1, we will place this n is equal to 1. This is 1. For the first term, we have, when t1, we have this value 4. So this is 4. In place of n, we will place 1. This is so a plus b is equal to 4. And for the second term, we have 6. And for second term, we have n is equal to 2. So n is equal to 2, a plus a, and multiply with 2 plus b. So this is 2a plus b. And now we'll solve this two equations. Equation number 1 is this, and this is equation number 2. 2a plus b is equal to 6. Now we solve this simultaneously. We'll get this value a and b like this. So this a and b will be placed here and here. So this is 2n plus 2. So the tn is equal to 2n plus 2, or it may be written down by taking common as 2n plus b is the nth term. So this is the nth term formula which is obtained by using this sequence. From this sequence we have obtained the tn term, so the nth term, which is simple at this stage. We'll see very complex patterns in the later stages. So this is fourth part. Here we have 0, 2, 4, 6. So for the first term we have 0 when n is equal to 1. When n is equal to 1, for the first term we have 0. So a n plus 1 plus b. So for the next term, for second term we have 2. For n is equal to 2. So this is this. So a plus b is equal to 0. 2a plus b is equal to 2. Solving simultaneously, so we see that a is equal to 2. So a plus b is equal to 0. So b is equal to minus 2. So a is equal to 2 and b is equal to minus 2. We will place these values here at a and b. Here at a and b. Sorry, here at a and b. We will place this value a and b at here. Here 2n, and in place of b we will place minus 2. So in placing minus 2, this is so this is 2n minus 2 and 2n minus 1. So place n is equal to 1, we will see 0. When n is equal to 2, this is 1 into 2, 2, and then 3, 3 minus 1, 2, 2 to the 4, and then 4, 4, 1 minus 1, 3, 3 to the 6. And you can see that this sequence is obtaining with this. So it proves that we have done the right way. Now the problem at 7. So we have 11, 21, 31, 41. So we'll place this value. So this is a linear term. So here we have t1 a for nth term 1. So this is t1 plus v. This t1 is basically 11. So this is in place of t1 we will place this 11. This is a plus b is equal to 11. So this t1 is 11, this t2 is 21, so 2a plus b is equal to 21. So this is, so we'll solve it and we'll get some difference. So a is equal to 10, and then similarly for using this, so get the value b is equal to 1. So this can be written down as 10n plus b. So in place of a we will place this 10, and for this value b we will place 1 here. So 10n plus 1. So now place 1 here in place of n. So first term will be 11. For 2, 20 plus 1, 21. So 3, 31. For 4, 41. So this is the way that prove that we have done it correctly. This is 14th, 15, 20, 25, 30. So we will solve it. For the n is equal to 1, we have t1 is equal to a plus b is equal to, this is t1 is 15, so we write down here. This t1 is 15, so a plus b is equal to 15, so 2a plus b is equal to 20. So this is 20, and by solving it we will get this a is equal to 5, and we place this value of 5 here. So 5 plus b is equal to 15, so b is equal to 10. So in place of b we will place 10, and in place of a we will place 5. 5n plus 10. 5n plus 10. This is, and we can prove that this is correct. So for n is equal to 1, this is 5 plus 10, 15. For n is equal to 10, this is 20, 10 plus 10, 20. For 3, 15 plus 10, 25. For 4, 5, 20 plus 10, 30. So we can then shown that this is correct. And now 19 number. So we have 7, 4, 1 minus 2. So this tan plus b, you place n is equal to 1. So this is t1 is equal to 7. For n is equal to 2, we have term 2, that is 4. So this is, so on solving we get this a is equal to minus 3, and by placing this minus 3 here, b is obtained as 10. So we can write here minus 3 and 10. In place of a, minus 3. In place of b, plus 10. So this is minus 3 and plus 10. Or we can say 10 minus 3. This is, both are same. So let's move to last problem. That is 25, 33, 21 and 19. So this is, so in place of 1 this becomes 25, so this is 25. For the second term this is 23, this is 23. On solving, a is equal to minus 2, and for this b is equal to 27, so we can place it minus 2 and plus 27. So when 1 is equal to 1, this is minus 2 plus 25, 27, that is 25. When n is equal to 2, this is 4 minus 4 plus 27, that is 23. So 6, and then 6 plus 27, 21, and so on. So this is all, and in the next session we will discuss the nth term of quadratic, cubic and exponential sequence, which is a little difficult part.